Now, the upper limit of impoundment 3 is Reveille Island. We had assumed that the narrowness of this channel in here, plus the presence of the island, would tend to isolate this entire section from the remainder of the lake. We have, in fact, found from subsequent data that if there is any isolation, there is indeed not very much. But however, for purposes of communication, we have continued to speak of this as impoundment 3 now, from Strawberry Point to Reveille Island, and the final section of the lake is the portion extending now from Reveille Island to the extreme upper end where the inlet water actually comes. Now, in terms of the depth, impoundment 4, or the fourth depression here, is clearly the deepest. At its maximum, it is approximately 400 feet deep. That's about right in here, right off South Bay. This is South Bay extending. If we were to follow South Bay straight out to about the middle of Lake Whatcom, we would find that in here it reaches approximately 400 feet, the deepest portion of Lake Whatcom. In spite of the fact that there are some people who say that this area is bottomless, we haven't found that to be true. 400 feet. Now, you may recall that a year or so ago, the city of Bellingham routed a portion of the middle fork of the Nooksack River so that it now enters Lake Whatcom. Developed a long tunnel, and that water pours in from the middle fork of the Nooksack into this portion here. This is the inlet, commonly referred to as the inlet, where the Nooksack River water actually pours in to Lake Whatcom. This new source of water, of course, allows the water authorities in Bellingham to maintain almost any level in the lake we wish. Some of you may recall that for many years in the summers, Lake Whatcom would drop down several feet in level, like the tide had gone out. But now, because we can regulate the flow of the water in from the Nooksack, the water level can be kept at a constant position. And we don't have this sort of tidal-like fluctuation all the time. Now, a great many people have asked us, so you have this model, just what can you do with it? Of what value is this thing to you? Well, there are actually a number of ways in which it has been and can be valuable. First of all, it allowed us to calculate the volume of Lake Whatcom. Now, actually, had we attempted to determine the total volume of Lake Whatcom by going out there and measuring it and computing this mathematically, this would have been a very difficult sort of task. But now that we have this particular model, and this model, incidentally, is built to a scientific scale so that we can take a formula and simply multiply in order to come up with the actual lake situation. All we have to do is to fill the lake with water and then multiply or plug the number of gallons, say, into our formula, and we can calculate the total amount of water in Lake Whatcom. In this way, we have learned that the total volume of Lake Whatcom is about 778,000 acre feet. That is to say, that if we were to spread all the water of Lake Whatcom out a foot deep, it would cover an area of about 750,000 acres. Quite a lot of water. In other words, I think that's about 65 trillion tablespoons of water. Similarly, we can calculate the volume of any portion of the lake that we wish in this way. Now, we hope also that we can utilize this model to understand the current patterns in the lake. For example, when the water is running in through the inlet here, we can see certain kinds of current patterns in the lake proper. But we hope that we can actually demonstrate those in the lake model and duplicate those patterns. If, when we have the shore topography all built up around the lake, perhaps we can set up fans then which will blow on the water. We can duplicate the wind situation, and we can actually duplicate the current systems of Lake Whatcom. The horizontal currents, and by regulating the temperatures in various portions of our model, perhaps we can set up vertical temperature situations, which of course are very important in understanding the lake and understanding the kind of water that we have. Another factor that is important to investigate is the sedimentation pattern. This Nooksack River water pouring in through the inlet is bringing with it a great deal of glacial till and other suspended material. Just where does this material go? One way of finding out, of course, is to go out to the lake and actually take core samples and track it in this way. This is difficult. It takes a lot of time. It would be much easier if we could duplicate the situation at the scale we have in this model and then calculate where the sediments are going in the lake proper and then confirm our observations. So we hope that we can evaluate the patterns of sedimentation and their transmission throughout the lake. We are also evaluating radionuclides, radioactive materials in Lake Whatcom. We hope that we can follow these materials and learn how they are transmitted from one part of the lake to the other. The model will be very useful in this regard. The final thing that I can think of at the moment that would be useful is determination of evaporation rates. We've actually already done this. We know that Lake Whatcom is a very large lake, and we know that it's going to lose a great deal of water by evaporation. Just how much water? We can determine this in this model. And this, of course, is a figure that would be very useful to us in understanding the total amount of water we have available to us in this community. There are probably a great many other things that I could say about how this model will be useful, and as we get further in our study of Lake Whatcom, we know that we will come up with things in which we can use this model that we have not yet anticipated. I have here only mentioned a few of the possibilities.